Why decentralization matters. Hello and welcome. Today we will go deeply into several fundamental concerns, such as what the core of decentralization is, what distinguishes decentralized networks from centralized systems. Of course, this is only the beginning. As we dissect the specifics of centralized against decentralized models, we'll see why the latter might be the next great leap for digital services. Paradigm shift that puts control back into the hands of the people. Join us as we go on this timely exploration. The first and second internet eras. The landscape of the digital world saw a tremendous transformation from the 1990s to the early 2000s, highlighted by the advent of services such as Google, Amazon, Facebook, LinkedIn, and YouTube. This period saw a significant reduction in the importance of once dominant centralized platforms like AOL. The following era, known as the Second Wave, witnessed the consolidation of power among for-profit digital titans known as GAFA, which included Google, Apple, Facebook, and Amazon. These firms shaped the digital experience by inventing cutting-edge software and services that surpassed the capabilities of open protocols. The introduction of smartphones accelerated this shift, with mobile applications becoming the primary medium for internet access. Users were drawn away from the open, decentralized services that defined the early internet by the ease and functionality offered by GAFA's proprietary software. While this technology growth provided billions with creative solutions and unparalleled access to information and communication, it also created several societal problems. The influence of these conflicts became increasingly clear in the different debates that took place. The proliferation of false news, the impact of state-sponsored bots, the contentious practice of user deplatforming, the implementation of rigorous EU privacy rules, and the identification of algorithmic biases all became important flashpoints. The spread of disinformation and the misuse of internet platforms for varied purposes highlighted the negative aspects of the digital age. Governments, cultures, and technology corporations have all faced issues as a result of the abuse of these powerful capabilities. The adoption of privacy legislation in the European Union, highlighted by the General Data Protection Regulation or GDPR, showed a rising recognition of the importance of addressing the ethical elements of data usage and online interactions. Furthermore, the topic of algorithmic biases highlighted the possible discriminatory influence of automated decision-making systems. As these technologies become more prevalent in daily life, concerns about accountability, transparency, and the ethical implications of algorithms arose. These societal disputes will only worsen in the future. The ever-changing technological world and its significant influence on society will almost certainly give rise to new difficulties, necessitating continual discourse and legislation to achieve a balance between innovation and ethical considerations. Finding long-term answers to these complicated difficulties will be critical as the digital era progresses to ensure that technology catalyzes positive development rather than adding to its societal ills. Zero-sum games. When a platform first launches, it normally tries to attract users as well as third-party complements such as developers, businesses, and media organizations, which are required to make the offering more valuable. However, as the platform gains wider acceptance, its control over users and other parties expands gradually. It eventually begins to compete with these third-party complements rather than collaborate with them. As a result, startups, software developers, creators, and other internet economy driving forces are no longer interested in building innovative services on the top of these centralized services, because the latter can change the rules of the game at any time to whip out competitors and steal their audiences and profits. Microsoft versus Netscape, Google versus Yelp, Facebook versus Zynga, and Twitter versus its third-party clients are all instances of such zero-sum games. Reaction to centralization. Government regulation of huge internet businesses is one proposed solution to centralization. This method, however, presupposes parallels between the internet and previous hardware-based communication networks such as phones, radios, and televisions. The internet, on the other hand, is a software-based network that can be re-architected through entrepreneurial innovation and market forces. The foundation of the internet is a basic layer that connects billions of programmable computers, providing a vast design area. With the correct incentives, connected computers may run different software, enabling a fast proliferation of ideas. The future of internet architecture is expected to include significant redesign of essential services, made possible by crypto-economic networks often known as blockchains. These are extensions of Bitcoin and Ethereum principles. In the future decades, this movement at the junction of technical creativity and incentive design is projected to alter essential internet services. Consensus, blockchains, and smart contracts. Blockchains are a blend of the qualities of the previous two internet eras, outperforming sophisticated centralized systems. Decentralization is frequently misunderstood. Contrary to common opinion, supporters of blockchains do not favor decentralization to avoid government censorship or to support libertarian political beliefs. Rather, they realize underlying difficulties with centralized systems. By utilizing multi-sided network effects, centralized platforms increase their value. Extraction of user data, competition for audiences, and profit maximization are common growth strategies for these platforms. The behavior has already been seen in operating systems such as iOS and Android. Third-party developers, on the other hand, see the change from collaboration to competition as a bait-and-switch, leading to disappointment. Furthermore, consumers' privacy is jeopardized. They lose control over their data, and they become vulnerable to security breaches. These issues with centralized systems are projected to worsen in the future. To retain and update state, blockchains use consensus processes. They also employ cryptocurrency to incentivize consensus process participants such as miners and validators. Today, other blockchains have devised solutions to the problems. These difficulties include block space, transaction speed, and latency. In light of this, Ethereum is transitioning from proof of work to proof of stake consensus. Ethereum is still the most popular blockchain for decentralized apps or DApps. DApps may be used for a variety of reasons, including gaming, social networking, financial, and others. Ethereum is a platform on which developers may write and deploy smart contracts. Ether, or ETH, Ethereum's native money, is also used to pay for the execution of smart contracts and transactions on the network. However, Ethereum is not the only blockchain capable of hosting DApps. Bitcoin is also expanding to provide additional functions beyond just being a store of currency. Bitcoin is built on a simple and secure programming language that can be used to build a variety of transactions and contracts. However, the intricacy and flexibility of the applications that may be created on the Bitcoin blockchain are limited. Particular benefits. Blockchain offers different benefits over early internet protocols developed by working groups or nonprofit organizations. To begin, blockchain agreements are enforced using open-source code. They're also vulnerable to procedures for voice and exit. Participants have a say through on-chain and off-chain community governance. Participants can also depart by selling their coins or, in extreme situations, forking the system. This alignment helps Bitcoin's endurance and success, even when new blockchains like Ethereum arise and flourish. Current blockchains have major limitations, notably in terms of performance and scalability, making it difficult for them to compete with centralized incumbents. The next several years will be devoted to overcoming these difficulties and establishing networks as the core layer of the crypto stack. Following that, the focus will move to designing apps on this upgraded infrastructure. How decentralization triumphs. To demonstrate that decentralized networks are preferable, we must be realistic and optimistic, with solid reasons. Developers are the primary architects of software and web services, and they include a huge and diversified set of component individuals worldwide. Even though the majority do not work for big software businesses, startups and independent developer communities make important contributions. In the 2000s, one interesting example was the fight between Wikipedia and centralized alternatives like Encarta. Although Encarta originally outperformed Wikipedia in terms of quality, Wikipedia's decentralized, community-driven approach allowed for fast development, propelling it to the top of the internet's reference sites by 2005. Encarta was finally phased out in 2009, highlighting the dynamic nature of comparing centralized versus decentralized systems. Multiple feedback loops, including core protocol developers, complementary network builders, third-party application developers, and network operating service providers, contribute to dynamic processes in blockchains. These loops are exacerbated by the incentives associated with the network's token, as seen by the fast development of Bitcoin and Ethereum. While centralized companies like GAFA have benefits like enormous financial reserves, massive user bases, and operational infrastructure, the dynamic and community-driven character of blockchains gives reason to be optimistic about their long-term viability. The Internet's next evolution. When compared to centralized competitors, blockchains provide a more compelling value proposition to developers and businesses. By gaining the backing of these important stakeholders, blockchains may be able to unleash a new wave of innovation and growth that outperforms the successes of large corporations such as Google, Apple, Facebook, and Amazon. Already, blockchain has begun to transform the financial industry by enabling remittances, lending, borrowing, saving, investing, and other transactions without the use of middlemen. We're also seeing new types of financial products emerge, such as stablecoins, which are cryptocurrencies tied to a fiat currency or a basket of assets, and decentralized finance. In contrast to centralized platforms, which frequently come with fully established apps, blockchains provide a platform for users to create and utilize their applications without the need for intermediaries or gatekeepers. This provides blockchains with several benefits over regular web services. To begin with, blockchains eliminate the need for confidence in third parties because the network functions on a consensus method that maintains the data's authenticity and immutability. Users may use the blockchain to verify transactions and contracts without depending on external authorities or middlemen. Again, blockchains provide a single source of truth for data by maintaining a shared and consistent record of the data across all nodes. Finally, blockchains improve network security and resilience by distributing and replicating data among numerous nodes that are encrypted.